here is our question 4 based on differentiation from first principles, part of calculus, grade 12. Now this question is particularly interesting because what we now have is f of x is equal to x cubed. So unlike the previous examples that I've done where the highest power was a square, here we have a cube. So we're going to start off by getting f of x plus h. This becomes x plus h all cubed. Now to break this down, to make it easier for us to work with, I'm going to split this up as x plus h all squared times x plus h. Let's now work on the x plus h all squared part. That's going to give us x squared plus 2xh plus h squared, and you're multiplying that by x plus h. So all we're doing from here is getting products. Remember, you guys, we introduced to products in grade 10, where in this case we have a trinomial times a binomial. I'm going to take all three terms and multiply it with x. That will result in x cubed plus 2x squared h plus x h squared. I'm now going to take all three terms and multiply with h. That gives me x squared h plus 2x h squared plus h cubed. Now we notice that we do have like terms. Okay, so here are our like terms, 2x squared h, and we've got x squared h. So when we gather those, okay, so firstly, there's only one term that has x cubed, so that would stay as is. Gathering these two terms, it becomes 3x squared h. Then we've got xh squared plus 2xh squared, which becomes 3xh cubed, xh squared, and the last term is h cubed. So this cannot be further simplified. We are now ready to go on to the first principles formula. So here is the formula. We're now ready to substitute. We're going to start off by substituting these four terms for f of x plus h. We had x cubed plus 3x squared h plus 3x h squared plus h cubed minus. Now for f of x, remember f of x is given to you. So if you go up, you notice that it was x cubed. So here's the thing about that formula. It's only one term and it's positive. So what you can do is you can substitute it in a bracket like this and then multiply the negative in. But I want you guys to notice that we can actually get away with not substituting it in a bracket because it's positive anyway. So if we multiply it with a negative, we get negative x cubed. So this would actually save us one step. But that can only work if there's only one term and it's positive. So it becomes negative when you multiply it with this minus. Next, we've got x cubed and a minus x cubed, so they cancel out with each other. We are now going to factorize those remaining terms. So we're going to pull out h as a common factor. In the first term, we're left with 3x squared. In the second term, 3xh, and in the third term, h squared, all over h. Remember, at this point, the h that you've pulled out as a common factor cancels out with h from the denominator. Now we notice that we still have terms that contain h. That is where we make use of the limit. It's going to be 3x squared plus 3x times 0 plus 0 squared. And we just use the 0 to show the substitution. Now simplifying, we're left with 3x squared. Remember, anything times 0 is 0, and 0 squared is 0, so we don't need to show that. This will be our answer. So we have used differentiation from first principles for x cubed, and our answer is 3x squared. Please remember to like, subscribe, and turn on your notifications for more content.